Assalamualaikum and good day. We are from Group Juniors are conducting a project entitled SCADA-based smart water feeding of chicken poultry. First of all, we would like to say thank you to Dr. Mahanijah for spending your time watching our video presentation. My name is Nurul Izzah binti Mazaid with my team members Muhammad Alif Izani Azri, Muhammad Iqbal bin Mesman and also Nurul Shazwani binti Cik Jailani.
Water quality control in poultry farms is very essential in development of poultry. Water consumption rates for chicks aged 4 weeks to 18 weeks is 200 liters per day for 1,000 chicks. Water acidification procedures have been developed to preserve the pH of drinking water at a chick standard of 4 or lower. The farmer can prevent many diseases in chick flocks and ensure proper chicken growth by monitoring the quality of the ingested water, which will definitely result in lower costs and increased income. The solution of water feeding can be automatically done with help of SCADA integrated into the tank and pipeline. For the problem statement, according to the industry standards, a poultry farmer should aim at achieving mortality of not more than 0.7% cumulatively over the first 7 days of brooding. In slow-growing breeds, this mortality can even be lower. Next, water resource control is extremely crucial in the poultry industry as water contributes to 80% of nutritional needs. Nevertheless, the problem of the conventional water supply system, such as acidic water, will imply a negative effect on the life of the chicken's breeds. Besides, a lot of poultry farmers are faced with tremendous obstacles which cause a major loss of investment and productivity at a high expense, leading to the little or no benefit at the end of the production period. Most of the broiler production will be affected if the chicken chicks are not survived in the early 10 days.
So the main objective of our project is to write the control algorithm using ladder diagram for SCADA module. It is used to perform an automatic water flow system. Next is to design a system that can be monitor and maintain the quality of drinking water before it is being distributed to the chicks. Lastly, to reduce the cost production and maximize the farm yield. Next, let's move to the next part, which is project scope. Smart water feeding system can be controlled by the supervisory, control and data acquisition, which is SCADA. SCADA is used to process the data and make the real-time decision. It also provides the high-level process of supervisory management. Next, for input and output programming, it is used to modify the supervisory control. For the block diagram, it consists of 3 parts, which is input system, control system, and output system. For the input system, it consists of start and stop push button, pH sensor, float switch sensor, and timer. For the control system, it has T-box telecontrol system and master station. Master station is for user to monitor the system. Lastly, for the output system, it consists of solenoid valve, water pump, counter, and agitator.
In this section, I will describe about the mechanical 3D design of SCADA-based smart water feeding of Chicky poultry. The design has been implemented using SketchUp Pro. There is a tank that is connected to the water pump. The water will be pumped from the tank to the poultry. Then, the clean water will be distributed through 3 pipelines in the poultry. There is the pipeline with the nipple in the chick's poultry. When the chicks pick the nipple releases a few drops of water to the chicks. The nipple will dispense a small amount of water each time it is picked, and it will reduce waste in chicks poultry. There is a tank that is connected to the water pump. The function of the water pump is to pump the water from the tank to the Chicky poultry. For the next part, the close-up view of the solenoid valve of water and biotronic acid, pH sensor, float switch sensor, and agitator inside a tank. The function of the float switch sensor is to detect the level of the water in a tank. After the water reaches a high level, the agitator will stir the water and biotronic acid liquid to make both of them completely mixed. Then, the pH sensor will detect the acidity of water inside the tank. The control room is placed outside of the Chicky poultry. The operator can monitor the process of water management through the SCADA computer system. All data displayed on the human-machine interface (HMI) can be adjusted or overridden by the operator.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqbal bin Usman. Okay, for the project demonstration, first of all, I will show some parameters used in this project. This project entitled SCADA-based smart water feeding of Chicky poultry has 4 inputs, 4 outputs, 3 timers, and 1 counter. Okay, as for the inputs used in this project are start and stop button. As you can see here, start and stop button, float switch sensor with high level and low level. Another input used is pH sensor. And as for the output used in this project are biotronic acid liquid valve, water valve, agitator, and water pump. Okay, for the timers, timer 1 is stir timer, timer 2 discharge water, timer 3 for biotronic failing timer, and counter is used to count how many refilling process occur in this project. Okay, next, I will demonstrate the system. When the start button is being pressed, inserted by 1, and stop button is inserted by 0, biotronic acid valve is open for 30 seconds to allow biotronic acid flow inside the tank. Biotronic filling timer will be counting up till 30 seconds and then trigger water pump valve to open and allow water flow inside the tank. Okay, so let's wait. Okay, then the comparator will compare if the float switch sensor is equal to 90. If the sensor is met, then the high water level is triggered. Then high water level status will trigger agitator. Agitator will stir the biotronic acid liquid and water blend together for 12 seconds. Then timer 1 for stir is counting up till 12 seconds. Then pH sensor will run its role to check the acidity level of the solution. If the condition is met, which is within the range between 4 to 40, that represents of 4 in reality, then it will trigger water pump to discharge the new solution of water for 18 seconds. Timer 2 will be counting up till 18 seconds before turn off the water pump, while at the same time counter 1 will count as 1. Okay, then the process will repeat again until counter counts up till 7 and then stop all the system.
In conclusion, this project successfully achieved the proposed objective of the control algorithm using a ladder diagram for a SCADA module. The SCADA system that provide a real-time monitoring allow concept fault to be detected. That objective had been achieved by monitoring and maintaining all the processes involved in the acidification process and water management. By fulfilling all the objectives, by making the system automatic and easy to be monitored, it can reduce cost of production and maximize the farm yield in the long term.